I'm gonna record this just so we can post it online for anybody that misses it. So uh, let me know. Should be able to send me in chat. There's a two and a two. You can click that and send a message straight to me if you need to. If you don't want it on the recording. Okay. All right. So howdy. We're going to start today with share, and I want to share. Let's do the entire screen. Why not? That puts everybody off to the side. All right, great. I want to start by looking at practice quiz 12. Yeah. Christine, yeah. Uh, where is calculator? There it is. All right, can you see? I can't see what you're actually seeing. Can you see my screen? Yep. Okay, great. So this is practice quiz 12. So it asks us to find the reaction order, and it's given us a bunch of information here. The first thing I want to do is to write my reaction rate before the experiment. They will always ask this question: what is the reaction rate before the experiment? And so you're always going to have your rate equal to some rate constant. We'll see later in the semester different rate constants, but this is often referred to as K sub 1, where that 1 is the reaction going forward. If they use a K minus 1, they might be referring to a reaction going backwards. Sometimes we'll see reaction A and reaction B. Um, and so then we're going to have our molarity of each reactant. And they're all going to be raised to a certain power. And that power we said was the order. And I can't seem to type today. My handwriting is bad enough. All right. So we're going to do NM, remember concentration in molarity moles per liter. And then we're going to do P for the next one. So one, two, three different reactants. So these subscripts, we don't know. Oh, superscript, sorry. We don't know what they are until we've done either a set of reactions. Refuses to go. There we go. All right. So to solve for N and M and P, we're going to have to look at the reaction itself. And so looking over here at my concentration of, let's see, selenic oxide or selenium. I don't know. Yeah, I never use that acid. That's a weird one. So notice we've got the initial concentrations and the initial rate in moles per liter per second. And so as these change per second. So the reaction rate will have to be determined in this case by comparing a couple of these different reactions. And so just while we're referring to them, I'm going to see if I can insert a column to the left. And I'm just going to number these reactions. Well, they gave me 7 of these. They might not all be needed, but they did a series of 7 reactions. And so, as we said last time, what we're looking for is to be able to find the ratios of any 2 reactions where only one thing changes. And so, starting off, I'm going to be looking for, uh, let's just do this acid here. So my selenium oxide, I've got a concentration here where it was started at 1 and then they've doubled it. Here they've tripled it compared to that. And then the rest of the places, they didn't change it. Now I don't have to necessarily start with 1, but I do need two values that are different. So I could do the 2 and the 3. I could do a 3 in any of these ones or the 2 in any of these ones. But I'm looking for a place where only one thing changes. All right. So in the first one, I can see that these are double the concentration of my selenium, but they're not changing between the two reactions. So this first reaction, I'm going to look at 1 and 2. And so I'm going to take the value for 2. And so let's fill our calculator far up. And so 2 second E. Now we should get that this is doubled, but I'm just going to double check it. And I get 2. So when I'm looking over here, I'm going to say I've got that concentration. So I'm going to just label it A. That doubled. And the rate, and so I'm going to go ahead and do my, it looks like it doubled as well, but I'm going to double check. So I'm going to take the 3.3 times 10 to the minus 7 and divide it by 1.66 times 10 to the minus 7. And that's close enough to 2. And so I'm going to say the rate doubled. And so N would be my order of the first reactant, and it is first order. When I double it, it doubled. I probably could have gone on and checked. Notice between 1 and 3, the reaction is the same kind of situation where only the first column changed. And so had I done that one, well, we're just going to trust it. This is 3 times that. But if I had done the 4.99, and divided by the 1.66, I should get that that's 3 times as much. And it's close enough to the 3. So N is equal to 1. Whatever change we make to this concentration, it makes that same change to our rate. Okay. So the next one up, I need to find M. And so notice it doesn't really matter about these coefficients. We're not really using those right now. And so looking at this one, I'm going to need to find a place where just these are backwards, right? So I've got I here and H there. Oh, they threw us for a little sneaky. So as I'm looking through this, I want to find a place where I have uh, this I change, but nothing else. And so it has to be something between these top section and the bottom section. And I'm looking for nothing else. So it can't be. So if I have this at 4, I need this at 2, this at 1. And so I could certainly do 6 and 1. So we could do that. Let's make that and that's blue. And we can do 1 now in blue. And we'll notice that this got twice the concentration there, but the H plus stayed the same and the selenium stayed the same. I could have gone in and looked at reaction 7, which changed this to 4, and reaction, oh, I thought I saw one. Reaction 5. So 1, 1, 1. And this went from 2 to 4. So it doesn't matter which of these we look at. So let's look at reaction 1 and reaction 6. So reaction 6, I've got 4 up from 2, so that's going to be twice as fast. And when I look at the rate here, 13.2 times 10 to the minus 7. Uh, let's see, how about you just joined us? We are looking at practice quiz 12, which is it's got both initial rates and the graphing stuff. And you guys feel free to unmute and ask questions as you need. It's totally fine. Um, okay, so 13.2 e to the minus 7. I'm going to divide that by that 1.66 e to the minus 7 from the first reaction. And I got 7.95, which is close enough to 8 times. So let's see what happened here. When we did this, we we doubled that, all right, because we went from 4 and 2, right? So that'll be double. And then we end up with the rate is 8 times. So in other words, we're going to be taking 2 and raising it to some power. And this power, in this case, I've got 2 i's here. I'm going to change this one to h. All right. I'm going to raise this to 2 to the mth power. Here, And so here, then, when I set that equal to 8, we see that m has to be 3. 2 times 2 times 2. All right. And so that gives me m. I've got n is 1. And then this depends. Notice it's not 6 times, but it does change triple the or third order, I guess is what we would say. So this one would be third order. You'll ask that. This one was first order. And so then all we really have to worry about then is for our H. So the H is this middle column. And I'm looking for places where it changed. So I've got a couple of different places. And I need to be careful that it's the only thing that changes. So I noticed a change between it here, 2 and 4, but it changed over here for the selenium as well. So looking for a place where this column changed, but nothing else changed. I could do 4 and 5. So let's make those stand out here a little bit. I don't know if the green stands up. There we go. So we could do this doesn't change. This doesn't change, but this changed. So I'm going to do the change from reaction 5 to reaction 4. In other words, I'm going to put the 4 on the top. So we should see that this was 4 times as much. Okay. And since the rest of it didn't change, I can compare it to this one. So we're putting number 4's value on top. So 6.66. And we're going to divide that by and you'll notice this is not in scientific notation. They do that a lot of times on these to make the graphs or values a little bit easier to understand. So they're just doing it for emphasis. It's not technically correct. So this should have been 4.2 times 10 to the minus 8, but then it'd be tougher to see how it compared to the others. All right, so roughly 16 here. All right. 4.2 10 to minus, yep. So let's think about what that means. So if this thing is 4 times, so I'm going to have 4 for my change that I did in my concentration, and I'm going to be raising that to In this case, we labeled it P, and we're going to set that equal to 16. And so 4 times 4 would be 16. So this would be first order. Okay. Uh, now I didn't, some of that value wasn't real super close, 18.9 or 15.9. It's not super close. So I'm gonna see if there's another place I can double check this. And so I'm still looking in this column. I noticed that if I did this one, I'd have 2 for everything. And is there a place I have 2 for the first column? Nope. If I had this as 1, 1, 2, this number 5 and number 1 I could compare because we can see that in number 1 I had 1 in this first column, and then number 5 I had a 1 times 10 to the minus fourth. Here I doubled the concentration for the H plus, and then over here I did not double my I minus. And so if I'm comparing 1 and 5, so we've doubled here the rate or the concentration. Let's look at the rate, 1.66 E minus 7, and we'll compare it to our number 5, which was again 0.42 E to the negative 7. And I got 4. Now to remember, we didn't have 4 times that concentration now. So we had twice the concentration. And no, I missed that earlier. I wrote that was so twice the concentration. So this to the P, this came out to be 4. This is actually second order. The problem I can't see chat. Somebody yelling at me in chat. Nope, that doesn't show me. Mm, I don't know. Anyways, this should be second order. That should have been second order. So let's scratch through that and make that second order. So 2 to the second. So it's a good thing I checked it. We had it right. I just didn't write the right thing down. So let's double check that that makes sense. So I'm gonna zoom out just a little bit. We can see that we doubled the concentration for the first one, and this is went from 16 to 32 roughly. So we'll call that close enough to 2. The second one, we went with number 1, and we were looking over here, and we went with 1. Notice these two are the same, and 6, and that allowed us to say here we've doubled that concentration for this one, and it is double the rate. All right, so that will be our first order. No, wait, one. Let me make sure I'm looking at the right. We said the right ones here. H was our P. Okay, yep. All right. I did I get that right? If I'm looking at I got 2 to 4, and then this is quite a bit more. What did we say that was? 13.2 divided by 1.66. That was 8. So we doubled it and we got to 8. And so that's third order, first order, second order. I'll buy all that. I'll buy all that. Now be careful when we originally wrote the rate. We originally put the I first. So uh, just be careful when you're comparing these. Okay. We'll stop sharing for just a second. I do have something to chat. Yeah, so as you want to know, is it safe to round? Usually pretty close. You do want to be careful about if it's exactly like point 0.5. That's usually a sign that the ratio should have been like 3 to 2 or something like that. Um, and so you might have to uh, go back and look a little closer at the changes. So sometimes we might look at it and say, oh, it's about double for the concentration, but unless we actually do the on the calculator and see that when we do that division, sometimes it works out to be that they've multiplied by 3 instead of by 2, and they're just really small numbers. But for the most part, yeah, it was pretty safe to round. We had seven. Share it again. Oop, there we go. So we had when I'm rounding a little bit, it's safe to round. But I want to be careful about if I had a value that was not really closer than this, I would be worried. And so what I did was I went back and double checked it, picking different reactions to see if I was really safe to rounding and if I had rounded it correctly. So I will say, generally speaking, if it's real within the if it's 3.9 or 7.9 and you bring it up, that's totally fine. But if it's 3.5 or 3.4, you might be worried. I would stop and worry about what was going on with it there. Good question. Okay, great. All right, the next thing that we have going on is this idea of graphical analysis. And they're going to give us this reaction. They're going to monitor one thing. So in this case, they monitor the concentration of their C4H6, and they're monitoring it versus time. And so this is butane, and they're taking it to octane, which is the liquid, at least temperatures probably. So as they went through, measured this over time, they measured those values. They didn't give us a whole lot of values, but that's okay. So I'm going to show you how I will. Let me go ahead and share my screen again. And so I will go ahead and show you how I will do these values in my calculator, and then we can do them also in Excel, much like we did the first time where we just copy these over. So doing them in my calculator, I'm going to make sure that a couple of modes are on. So first I'm going to go to mode, and I'm going to go all the way down till it says next. So it should have a next on your mode screen. I'm going to turn Stat Wizards on and Stat Diagnostics on, and both those should be on. So for some reason, Stat Diagnostic defaults to off, and so you have to make sure it's on. All right, so here's the key is I'm going to be following in our notes this graph or this some of this out of the way. This little table. So this little table has um if it's zero order, the rate doesn't change with the concentration. If it's first order, if I double the concentration, I'll double the rate. If I half the concentration, I'll get half the rate. But what's key for us is what's needed for a straight line. So these things that say something versus time. Notice these are all versus time. So these are our X values. So I'm going to go ahead and set this up to do a bunch of graphing. So I'm going to go to stat and I'm going to hit edit. And I've already got a bunch of values in. So if I just hit clear here, it's going to clear the one value. And that's not what we want. So what I'm going to do, I'm going to go all the way to the top and I'm going to hit clear and then enter. And I'm just going to get all this old data out of here. You can also do it from where I hit stat. You can also, there's an option to do it there as well to just clear that whole list. So there's all my lists cleared. So had I hit stat, I could have hit this clear list and it would ask me for which one. And so the lists are L1, L2, L3. That's in blue on this calculator. So if I had to clear list one, it would do that. Now you could clear more than one list. I don't know if there's a command to clear all the lists, but I can certainly come up to this clear list and I could have put comma L2, comma L3, and it would have done that as well. Okay. So going back to my stat, I'm going to edit these and I'm going to add these values 0, 1,000. So this is my T. So 0, 1,000, 2,000, 3,000. And you'll notice it changes this, says L1 and it says value 4. And so that tells me which value we're on. Okay, and I'm gonna go ahead and put in my L2. So I'm putting in my concentration, so 0.01, 0.00629, 0.00459, 0.00361. And I'm gonna double check that these are in the same place. The blank is in the same place. Okay. Now, while I'm here, I'm going to go ahead and generate the next couple of columns, but I don't want to have to figure out what the ln is of something and what 1 over it is. We certainly don't want to type that in. So we can use that just like we would in Excel. I'm going to come over here and I want to make this whole thing follow a formula. So I'm going to go up to L3. So I've got it highlighted and hit enter, and it lets me edit it down here. So if you don't see the flashing cursor on the bottom, uh, that's where it's at. And if you haven't done that, make sure you hit enter on the L3. All right, so in this case, I want ln of A. So notice it's not log, so it's ln and A being my concentration. So my concentration was L2. And that's the hardest part here is just keeping up. Usually I just come in here and I label this L1 and maybe this one L2, just so I can just so I can kind of keep up with them. So this one is ln of L2, second L2. And then it says I need 1 over, so I'm going to do that here. I'm going to go, I went over, and then I'm going up and hit M4. And so there's L4, and I'm just going to do 1 divided by second L2. And that should populate that for me. So I've got 4 columns. The first column will be the same for all of these. That's the time. And so I'm going to make 3 graphs, one for 0, first, and second order. Third order is a lot tougher, so we're not going to worry about it for unless we need it. So if I'm looking at this, then I need to see what those plots look like. First thing I like to do is I come in here to y equal and make sure these are cleared. And they look fine. Excuse me. Ugh, would not let me pause. So I apologize. I tried to mute it, not in time. So y equals is where we're used to put in our formulas. But what we actually want is this thing called stat plot. So I'm gonna hit second and then y equals. And this allows me to have a series of stat plots. We really only want one on. And so you can turn them all off with number 4. I can also go to stat plot and I could just click on the number or the value for one of these. So I'm gonna you can turn them on and off, the first 3 in the same kind of place. So we can go up to the top and switch between them. But I just want one on at a time. I like this first one, the XY scatter. And we could change the markers on it if we wanted to. If it's a color calculator, you can change the colors. But we wanted L1 is our X, and we wanted L2 as our Y. So let's go ahead and set that up as L2. So that was second stat plot. I went to number one. I turned it on, make sure it's L1 versus L2. Now to see this, I'm going to hit graph, and you'll notice immediately that this is almost never zoomed in the right place. And so what we have to get used to hitting is zoom. And the one we want is number 9. I'm going to scroll down to it, but you can also just type the number 9. It says zoom stat. And this is why I only like doing one graph at a time. And so here I've got this graph, but I can't really see if it's a straight line. It doesn't look very straight to me. So I'm going to check the next one. So I'm going to do second stat plot, go to number 1, and I'm going to go ahead and turn this over to L3. So L1 versus L3. Now I'm going to hit graph, zoom, 9. And that looks a little bit straighter, actually quite a bit straighter. All right. Maybe it's not perfect. I'm not really sure if that's going to be my best. I'll go ahead and check the other one just for fun. But there's going to be a better way. And this, I'm going to do my L4, graph, zoom, 9. And the problem is I have a hard time seeing. This looks pretty straight, but I don't, so did the last one. With only 4 points, it's hard to really kind of make that judgment call. So what we're going to do here is get the best fit line. So the way I'm going to do that, I'm going to go ahead and quit out of this. I'm going to go stat, and then I'm going to hit calculate. I'm going to go over to the calculate, and it's number 4, linear regression. That's the one we're used to using in our best fit line in Excel. Now, if you don't have the stat wizard on, it won't show you this screen. And so you'll have to go from to give some extra information when you do it. But I'm looking up here, it says AX plus B. So A is my slope, B would be my B intercept, and then it's going to also, if I have R squared on, give me the value for my R squared. And so the closer to 1 it is, the better. It's looking for my list. So right now it's doing L1 versus, we want to do L3. L2 wasn't that good, but let's go ahead and check it. Second, L2. And we'll go ahead and calculate it. So it says the slope is -2 times 10 to the minus 6. R squared is 0.917. That's not terrible. It's not terrible. And so usually I would kind of write that down, or I'd snap a picture of this, or I'll come back to it after compare the next one. So I just went stat, calculate. I'm going down to 4, hit enter, and I'm going to change this one to L3 and calculate is 0.978, which is already better than what we had for the first one. So that one looks much straighter. But I'm going to go ahead and hit stat again, calculate, number 4. And I'm going to come down and change this to L4. And it says, oh man, that's a lot of 9s. That's got to be our best. It's almost 1. Now, what I would like to do, if this is L1 versus L4, is I'd like to see this best fit line. They said it's a great line. So I'm going to go stat, calculate, number 4, L1 versus L4, and then I'm going to come down here to store the equation. And this is where things get a little difficult at first. We're not used to using this, but we want to use the thing called variables, which I have to find. Oh, maybe I can just do math. Nope. That's where a lot of the cool stuff is. Absolute value, all that good stuff. Trying to think of where the variables were. Variables right here. I'm gonna hit variables, and then I'm gonna do over. So it's next to the clear on the 84. And so when I click that, I want to go over to 1, to Y variables, and then I want number one, and I'm going to just choose one of my Y values. And so when I do this calculation, it's going to store that. It gives me my Y equals AX plus B in this format. Here's my R squared value. I need to write that down if I need it. But it also stored it under my Y equal, and it's got this written out as the equation to a line. Now what I'm going to do is I could graph that, but what I'm going to do is go back to stat plots. And we did L1. I'm going to make sure it's the right one. L1 versus L4. I'm going to hit graph, and you'll see it draws my line in for me. It draws my line across. Okay. So that's the L1 versus L4, which if I go back and look at my stats, L1 was time and L4 was 1 over the time. I'm sorry, 1 over the concentration. So that was second order. So that tells me that we can do an integrated rate law, and it looks like this, and it would allow me to predict the speed and the concentration at any given time, as long as I know the initial. I know that it's second order here. And then this K, if I actually want the value for K, then when I come back to my Y equals, it says the slope on the second order is equal to K. So my K is this 0.05899. That's the actual value for K for my best fit line for this data. So it's second order, and it's got a slope of 0.06 basically. We'll use sig figs here, just more than we think we need. So usually sig figs aren't going to be the issue on those. So yeah. And then if they ask me to find the half-life, I could also plug it in here. And so 1 over K times the initial concentration, and my initial concentration was 0.01. All right. And so we could use that to find how long it takes for half of it to be gone, half of my concentration to be gone, which 0.0459, we can see it was pretty close at 2000, the first place. And so there's a second half-life where we lose half again. And so the easiest way of doing that is to take, when you hit the half, you're going to put it in here for your concentration initial. So you just basically treat the answer for the first half-life as your initial for the second half-life. Okay. And stop sharing. We'll stop there and make sure nobody has any questions. Everybody looks like they're pretty good. Don't be shy. My animals are all over the place. Bastion says he's good. All right. All right. So we will do a lot of these, and it really comes down to looking at this table that is the integrated rate law and the orders. There's a couple different versions of it. So one is in my notes, and then there's a slightly different one in one of the test handouts. So I've opened all those up. You should be able to get in and see those. And would you like to have it according to me? Sure. I'll put it up in Blackboard. How about that? Okay. Sounds great. All right. I'm going to stop it there, put it up into Blackboard. And so I'll be around. Certainly email me if you need me. But other than that, be safe out there. The roads are kind of slick. So be safe. Have a good one, everybody.